We're now going to look at mutually exclusive and independent events. So question 1, our first guided practice on this, says events A and B are mutually exclusive and the probability of A is 0.2, the probability of B is 0.4. So if I put that information into a Venn diagram, we've got the probability of A is 0.2, B 0.4. So we know the total of probabilities of all events is 1. So we're going to, of all outcomes of an event is 1. So we're going to do 1 subtract 0.6, which is the sum of 0.4 and 0.2, and we get 0.4 there. Now the reason why these two circles are not overlapping is because they are mutually exclusive, so they cannot happen at the same time. So part A is asking for the probability of A or B. Now, you will have seen on the input slide that for mutually exclusive events, the probability of A or B is equal to the probability of A plus the probability of B. So I'd always make sure that you write this down at the beginning of your question. So we're doing 0.2 plus 0.4, which is 0.6. Part B is the probability of A but not B, and that is equal to the probability of A and not B, which is 0.2. So that is exactly equal to the probability of A. The reason why that is equal to the probability of A is because A not B, A and B can never happen at the same time, so that's just going to be the probability of A. For part C, the probability of neither A nor B, that's going to be when A and B, or A or B, sorry, do not happen. So we've got 0.4 there. For guided practice 4, this is a really quick one. We're told events A and B are independent and we're given the probability of each event. Now in that input slide, you would have seen that if events are independent, the probability of both events happening at the same time is the probability of those events multiplied, so the product of those probabilities. So we're going to do the probability of A and B. We're going to say that that's equal to the probability of A multiplied by the probability of B. So we're doing a third multiplied by a fifth, which is 1 over 15. For guided practice 5, you were given a Venn diagram, so I'd refer back to that Venn diagram whilst you're going through this. And this was a Venn diagram showing the number of students in a particular class who watch any of 3 popular TV programmes. For part A, you're working out that the probability that a student chosen at random watches B or C or both. So if you look at the Venn diagram, the 2 circles that are of B and C, you've got 4 numbers in those circles. So we're going to do 4 plus 5 plus 10 plus 7 to find the total amount of people that either watch B or C or both, remembering that overlap with B and A still includes people that watch B. So 4 add 5 add 10 add 7 is 26. So the probability that somebody watches B or C or both, that is equal to 26 over 30, which is equal to 13 over 15. For part B, it says determine whether watching A and watching B are statistically independent. So what we need to remember here, for statistically independent events, we know that the probability of A and B is equal to the probability of A multiplied by the probability of B. So if we can find these 3 probabilities, we can decide whether A and B are independent events. We know that the probability of A and B is that overlap of A and B, where there are 4 people, so that's 4 out of 30, which is 2 over 15. The probability of A, that is the probability of being in the whole circle of A, so you've got 3 add 4, over 30, which is 7 over 30. The probability of B, we've got 4, add 5, add 10, because we've got that overlap with C and B, over 30. So that is 19 over 30. So if we work out the probability of A multiplied by the probability of B, that is equal to 7 over 30 multiplied by 19 over 30, which is equal to 133 over 900. That is not equal to probability of A and B, which was 2 over 15. So we know that they're not independent, but we need to now write a conclusion to say that. So probability of A multiplied by probability of B was not equal to probability of A and B. So events A and B are not independent.